Hey guys, my name is PyTorch and welcome back to another video. Today I'm going to show you guys, or help you guys make your first PyTorch computer vision model. I already made it over here, I already trained it. I'm just going to walk over these blocks of code and just show you what I did to make this model and train it. And then I got the data that we're working with is from Kaggle. I'll put the link down below. If you guys don't have a Kaggle account, make one already. Head to settings, go down, go to API key, get the JSON file and put it to your file system. Otherwise you cannot download the dataset. Over here I downloaded the dataset over here. This is how you zip. I unzipped it over here. Import Kaggle Hub. This block of code is in the, you can copy when you go when I give you the link, you click on it, it'll say code in this green button, this green block. You click on it and it'll show you the code. You copy that, then you follow these rest of these steps to get it extracted into your system. I'm pretty sure you can also download the whole dataset too, but that will just take up a lot of space on whatever you're using, whatever laptop, PC. You can just unzip it and put it here onto the to the cloud. No reason to waste space on your PC, right? So over here, so since I already have it downloaded, I already did it. I already imported Torch, Matplotlib, Torch Vision. We're gonna need all this to make our model. Ignore this. This was something else I was experimenting with. We can just get rid of that. But here, this is where we get our data to training and testing directories. So here, this is all battery, biological brown glass, cardboard. It's all there's 12 labels, I'm pretty sure. And we're gonna split them into training test directories, so they each have one of these directories. So when we run this, we should have a test with all that. Yep. Train with all that. Yeah. So now, what this code overdoes is in the split, it's going to get all the files for each directory. It's going to split 80% of it into that directory. So it's going to come here, it's going to come to this, directories over here. It's going to go in battery, take 80% of battery, put it into training, 20 twice. And do that. Same for everything. So when we run that, it's going to take some, there you go. Should be 20% in there. Yep, 20%. Sorry. And then here, 80%, bulk of it. Oh, sorry, I just mixed them up. This is 80%. This is the 20%. Sorry, I completely misread that. So now we're making a Paxos path, a type Paxos path, a training directory and testing directory. We're gonna need this later, cause then we're gonna turn this, you see, into we're gonna visualize this data, right? So we first put the Paxos path in a list where we go iterate through and find the JPEG that end in JPEG, and then we get a list of all those files. So it's going to go through all the training directory. It's going to get all the JPEG files from each of these mini directories over here, and then it's going to choose a random path from it, and then we're going to show it. From PIL we import image. We show the image height, width, class, and the random image path. So we'll use this one, and it's a 434 by 400, 534 by 400 size image. And this is shoes. This is shoes right over here. So over here we're gonna make it more visual and show you what each of those what this means and how we're gonna put this into correct format for our model, right? Because whenever we put things into the model, we want it to be in tester format, right? So over here we made a matplotlib. We made a plot from matplotlib, and then we made it size 10.7, and we wanted to get the images array. This is a NumPy array. This is a tensor by any means. This is we're showing this as a NumPy array, and then this is the shape. It's gonna be height, width, color channels. That's the key thing. I want you guys to notice when we convert things into NumPy and we have to put them, and we're using it for matplot to show. We gotta and we're showing it the shape of it. The color channels always come last for NumPy. When it's tensor, color channels always come first. It always comes first, right? we disable the axis, put as false, and then here 534 by 400 pixel image with 3 color channels. That's the format. But remember, in tensor format, correct tensor format, when we put into the model, when we want to put into the model, it's going to be color channels first, then height and width. That's typically the way it goes for it to fit inside the model. But yeah, here's the images in an array. You see all the numbers. And then, so for this, we're going to use a pre-trained model with it already pre-trained weights. We just get those weights, and we don't have to create the whole architecture because that is super complex, and I'm not a crazy engineer like that. So I'm going to use things that people already made and use it for my advantage, right? So what we can do is we're going to use efficient net B2. I'm pretty sure is B0 to B7. It gets bigger and bigger, larger models, and larger models are usually more. It gets more parameters, it's usually more accuracy. But I'm on the Mac here. You know what I'm saying? And sorry, I'm not on the Mac. I'm just running a simple model. Like, it's just trying to classify. I don't need a huge model. I'm not training to classify like millions of things, like everything in the world. I'm just 10, 12 things, right? And so we can just use the pre-trained model with weights for that, and we don't need to use a big model. We can go B2. B2 is like right in the on the lower end, but it's good enough for this. So we get the weights by performing this block of code over here. We get the weights. We get the efficient B2 weights, and when you put dot default, it gets the best weights. I'm pretty sure that gives us the best pre-trained weights. That will yield us the best results. And we're gonna get the transform, because when we put into data loaders, we're gonna need a transform. So you can get the transforms that the weights were, whatever the weights were trained on, whatever the input got transformed into to modify to work with the weights. We can get those transforms from the default weights that we got. If we just do weights that transform and we get out of the transform, this is what it performs. So the data transform. You get that. Right over here, we're gonna make I'm just gonna write a py file just to so we can make our training data loader, test loader, class names over here. This is just gonna get us our class names, our test data loader, and train data loader. You just put the batch size, parameters, number of workers, transforms is gonna be auto transforms, test directory, and training directory. So we put all of that over here. Run that. You get it all 12 classes over here, and then our data loaders. And then right over here for completeness, we're gonna get the weights again, and then we're gonna get the model. We're gonna do model the torch vision dot models dot efficient B2. Weights are equal to the weights that over here, and we're gonna send it to the device because we want to write device agnostic codes. Otherwise, we don't want to generate many errors. And then using did I run this? Okay. I'm gonna. I think I have to download Torch info again. But using Torch info, we're gonna get a summary of the model, how it looks like. But you'll see, guys, that over here, see all these are all the weights and buys over here. These are all trainable. So we have 9,109,994 trainable parameters. So yeah, guys, well, you guys will notice that, like I said, these are pre-trained weights. We don't really need to update these weights. We don't really need to train these weights, right? So, but only thing we're gonna need to train is this over here, because this is giving out 1,000 outputs. We gotta match that. We need to match these outputs to our number of class names that we have. We don't have 1,000. We only have 12. The green glass, plastic, all that, right? So what we do here is for param and model.features of parameters, we're gonna cut requires grad false. So this is gonna freeze the layer. This is gonna freeze this layer over here. Everything above everything above the classifier, it's gonna freeze those layers, so they won't get updated during the training process. The only thing that'll get updated is the classifier. So we need to modify the classifier. We can't be getting 1,000 outputs. So what do? We're gonna modify the classifier. So model.classifier equals torch. And then so we're basically rewriting it. And instead of, we have to have the same in features. It requires 1,408. But instead of the out features being 1,000, we're gonna have it as the output shape. The output shape being 12, right? So over here, we put model Input size 32, 3, 288, 288. By the way, I should mention this. B2, I'm pretty sure every B1, B2, B3, they all take different, input sizes. B2 is 32. The batch, that doesn't matter, but it's 3 by 288 by 288. Pretty sure. B0 is like it's not that. It's like 224 by 224. So it's all different. So we're gonna column names, input size, output size, number of parameters, trainable. And then our column width is B20, and row settings equal var name. We're just making the summary over here. And we're gonna run this. Well, you have to run everything over here. 12, right? So we set it to 12. Now the train up parameters is way down from 9 million to 16,908. This is what we're gonna update to match our data to get the correct predictions. So over here I'm writing just a training script over here, so it makes it easier. This is just a bunch of just the normal, just training, printing out epoch, train loss, train accuracy, all that. And then we're gonna use cross-tree loss since this is multi-classification, and then optimizer we're gonna use atom, and then our model parameters, and learning rate's gonna be let's keep it. We're gonna train this again, but so we're gonna use 0.001. No, that's the normal learning rate to use with atom. We're gonna use that, run that, and then we're gonna start training. Yeah, let's do it. So I'll catch you guys in a bit. I'm gonna wait for it to be done training. Alright guys, our model's done training. Did pretty good. It didn't go up crazy, but it's a high accuracy and a decent loss. And it went from 93.65, and it rose to the highest we got. I'm pretty sure it's 95.63, isn't it? But 95.4 would be good enough for the purpose of this video, because now we're gonna get our own custom image. So I took a picture of my dash shoes over here. I put it in the file system. Slash shoes at JPEG, and we have taking some time to load, certainly. And then over here, alright, here we got my dash shoes. I don't know what brand these are, don't ask me. I don't know what he's wearing, but these are his shoes, and I just took a picture of it for the purpose of this video. And over here, we're just doing everything that we did with the earlier, the data set that we had. We're transforming it. And this over here, we actually created auto transform. We just recreated the thing. We didn't even use we didn't get the auto transfer from the weights. So we just created the transform, and then we transformed this image, unsqueeze it, because we have to get into batch form. We have to have a batch dimension in order to go into the model, otherwise it won't work. And then over here is making some predictions. Apply softmax to get the pred probabilities, and apply argmax to get the class label, the correct the predicted class label. And with that, we can, this is a function, we run that, and then we're gonna put our image already over here. I already ran it. I don't want to show the surprise, but will it guess his shoes? Out of all these, where is it? All of these possibilities, will it guess that it's shoes? And how confident will it be? So we put the class names, all the 12 of the class names that we have. Will it correct, guys? Let's see. The function that the model that we made, the PyTorch computer vision model that you probably first made in the first time, will it predict some random shoes that my dad wears are shoes? Let's see. Let's find out. Oh my god. Prediction shoes probability 93.5%. There you go, guys. That's the power of machine learning. You can do a lot of things with a lot of great and fun things with it. Next video, I'll be using more fun data sets, or just doing more fun things and just garbage classification. For just purposes of the video, just a basic simple tutorial into computer vision and making your first PyTorch computer vision model with pre-trained weights and a pre-trained model. So here you go. It's pretty cool. Like, wow, I really just did that. I just made a whole model that identifies or classifies types of garbage. That's really cool. So leave a like down below. I'll leave the Kaggle dataset link down below. You guys go download it if you want to replicate this code and see for yourself if you haven't already. But yeah, that's it. Thank you for watching, and I'll see you in the next one.